Hi, hello, welcome to Knowledge Center. In this video, let us solve few more questions on the previous KPTCL question paper, which has been asked for the post of assistant engineering in the electrical department. So now let's begin with the very first question. So in the question, it has been clearly mentioned that you need to find the power. So let me read out the question here. If the periodic current 2 plus 6 sin omega t ampere is applied to a 1 ohm resistor, then the power dissipated by the resistor is, they are given some 4 options. So you just need to find what is the power dissipated in the resistor of 1 ohm. So we know the power formula, that is I square R. Okay, so what is this I square? When we consider periodic, means sinusoidal waveform, I square means it should be a IRMS current, IRMS square. So first you need to find the RMS current here. In the equation we have 2 plus 6 sin omega naught t. So this 6 stands for Im. This equation stands for Im sin omega t. So 6 is a maximum current, it's not a RMS value. So you need to find RMS value of that 6 and then you need to take the solution resultant current. Okay, so for these kind of equations we have to find an RMS value. To find the RMS value, we have the formula something like this, that is square root of first quantity, that is a naught square plus a1 by root 2 whole square plus a2 by root 2 whole square, so on. Here we have only a naught and a1 quantities, that is a naught is 2, a1 is 6. So we can take only these two and get the IRMS. To get that IRMS, we can do it like this: IRMS equal to 2 square plus 6 by root 2 whole square. So once it takes 6 by root 2, 6 square is 36, whereas root 2 square is root 2 square square and root 2 will get cancelled, so remains only 2. So 36 by 2 is 18, 18 plus 2 square, that is 4, 18 plus 4 will be 22. So IRMS will be square root of 22. So once after getting that IRMS, we can find the power. So power is equal to square of IRMS into R. IRMS is 22, so square root of 22 is the IRMS. So if you take square of it, then square and square root will get cancelled, so we get only 22 into 1 because resistance is 1 ohm. So 22 watts will be the answer for this given question. The very simple thing is the basic equation should be the funda here. You need to understand basic equation. So RMS value of sinusoidal equation has to be given like this, FRMS. I hope this is very clear for you. Now if you want to watch my previous videos, you can have a link in the description, and also on the top of this, right top of this video, you will get the link. Please click on that and watch my previous videos. Now let's move on for the second question. So second question is about simple logical question. If 6p is so 46,656, what will be the value of p minus 2? So for that, first you need to find the value of p. So let's find p now. P is equal to 46,656 by 6. So once you start simplifying this, see, you get 6 7s are 42. So when you got first number as 7, in these 4 options, we can ignore the B and C option because they are not starting with 7. So we can ignore those two. We left out with the remaining 2 now. To find a final answer, you have to calculate p. So once after getting p, the p minus 2 will be 777.4. That would be the option A is the answer for this. In the third question is also a logical question. Pick the wrong term in the series. So here we have two kind of series. One is 6, 8, 6, 9, 14, 22 and 30, and the other one is 8, 12, 18, 26. How we split it? Let's look into that. So first series says that 6 plus 3 is 9, 9 plus 5 is 14, next odd number 14 plus 7 is 21, 21 plus 9 is 30. So here instead of 21 we got 22. So here only we got the answer, but we have to cross check it. So also go for second series now. In second series, 8 plus 4 we got 12, 12 plus next even number 6, 18, 18 plus next even number 8, that is 26. So all the numbers are correct in the second series. So clearly we have a point that 14 plus 7 should have been 21, but we got 22. But also you can check the 21, if it is, then 21 plus 9 would be 30. So 20 instead of 21 you got 22. So option C is the wrong answer here. I hope this is clear. Now let's move for the fourth question. An electric field is created by two parallel plates. At which of the following points is the electric field the strongest? So this is the electric field we have. Means there are two plates, positive and negative. In between these two we have the electric field. So what is the electric field where we have the strongest electric field? That's the question. So we have four options for that as usual. Now the basic funda of this electric field is we have the relation like this. Electric field can be given as voltage applied by the distance. So if we vary the distance between the two plates, then electric field will get vary, or if we vary the voltage, then the electric field will be varies. But in this case the electric field, the supply voltage is 40 volt and the distance is 0.04 meter, that is constant. So the electric field is not going to vary, it is going to remain same at all the points. Okay, so option D will be the answer for this kind of question. The electric field is the same at all the points. But you need to be very careful that if the plates are of a different polarities, positive and negative, in this case the electric field will be same at all the points. But instead of this, if the plates are of same polarities, like both positive or both negative, then the electric field in between those two plates will be zero. Okay, that is the point you need to remember. Now let's move on for the fifth question, and it would be a last question for this video. A 4-point starter is used to start and control the speed of dash. So there are four options given: DC series motor, shunt motor, compound motor, and none of the other. So here DC shunt motor will be the option, because look at this circuit here. For this DC shunt motor will have four terminals of starter. One is for line, the supply voltage, the other one is the return path, that is neutral, and field and armature will be remaining two paths. If it go for a series motors, then you will have only one terminal, because both the field and armature will be on the same line. But here we have two different paths, and in field we have the varying resistance, that is rheostat. By varying this rheostat we can control the flux. By controlling the flux we can control the speed of a motor. So for weakening the field weakening resistors has been added here. So option B will be the answer for this question. We have 4-point starter for